So welcome back again. Let's continue with our learning journey. And we can define heat as the transfer of any. We can define heat as the form of energy because heat is a form of energy that is transferred from a hotter region to a colder region due to temperature difference. And in this particular topic, we will be we'll be defining heat capacity and specific heat capacity of a body, and also as well as um, getting to dive deeper into what happens when heat is transferred from a hotter body to a colder body. And we can say that when heat is transferred from a hotter body to a colder body, that the temperature difference experienced by that body is dependent on the mass of the body and the specific heat capacity of that body. What I'm trying to say that when a body loses heat or gains heat, the change in temperature, how the temperature will change depends on the mass of the body and the specific heat capacity of the body. In other words, we have this quantity of heat lost or gained is equal to the mass of the body times the specific heat capacity of the body times change in temperature. This is change in temperature. We have Q is equal to NC change in theta, where Q now is the quantity of heat, measured in joules. M is the mass of the body, measured in kilogram, where C is the specific heat capacity, measured in joules kilogram per Kelvin, joules per kilogram per Kelvin, sorry, or joules per kilogram per Celsius. And we have the change in theta, sorry, change in theta to be change in temperature. Change in theta should be change in temperature. That is final temperature minus initial temperature, measured in Kelvin or Celsius or degrees Celsius. So this is the formula for the quantity of heat gain or lost. And like I said, the temperature change here, the temperature change experienced by this body is dependent on the mass of the body and the specific heat capacity of the body. And now let's define what specific heat capacity of a body is. We say that the specific heat capacity of a body is defined as the amount of heat required to raise a unit mass of a body. The amount of heat required to raise a unit mass of a body by 1 Kelvin or 1 Celsius is what we call the specific heat capacity. The amount of heat required, that amount of heat required to raise the temperature of a body, of a unit mass of a body. Note this keyword, unit mass. Please don't forget this. Don't forget this keyword. Unit mass of a body by 1 Celsius, 1 degree Celsius, or 1 Kelvin is what we call the specific heat capacity of a body. It is the amount of heat required to raise 1 Celsius, to raise 1 unit mass. The amount of heat needed to raise a unit mass of a body by 1 Celsius or 1 Kelvin is what we call the specific heat capacity of a body. While the heat capacity of a body, while the heat capacity of a body is the amount of heat required to raise the temperature of the body by 1 Celsius or 1 Kelvin. These definitions are similar. In specific heat capacity, the amount of heat required, specific heat capacity of a body is the amount of heat needed to raise the temperature of a unit mass of a body, to raise the unit mass of a body. Here, in specific heat capacity of a body, the unit mass of the body is being raised by 1 Celsius or 1 Kelvin. But in heat capacity, the unit mass of the body is not needed. It is just the amount of heat needed to raise the temperature of the body by 1 Celsius or 1 Kelvin. So note this, JAM can come and hide questions and be like, the amount of heat needed to raise a unit mass of a body is what? Specific, specific heat capacity of the body, heat capacity, and other options. Don't let it confuse you. The amount of heat required to raise a unit mass of a body is what we call specific heat capacity of the body. Let's talk about heat capacity. I would say that the heat capacity of a body is defined as the amount of heat required to raise the temperature of a body by 1 Kelvin or Celsius, or by 1 Celsius. That's what we call heat capacity. This is the amount of heat, that amount of heat required to raise the temperature of a body by 1 Kelvin or 1 Celsius. Hence, we have it like this. H is equals to M times C, where M is the mass of the body, and C is the specific heat capacity of that body. Remember, mass is measured in kilogram, while the specific heat capacity of the body is measured in kilogram, joules per kilogram per Kelvin, or joules per kilogram per Celsius per degree Celsius. Now, remember, specific heat capacity of the body is the amount of heat required to raise the temperature of a unit mass of a body. It has to be the unit mass of the body that is raising. It has to be the temperature of a unit mass of the body by 1 Kelvin or Celsius. That is the specific heat capacity of that body. While in heat capacity, the amount of heat required to raise the temperature of the body by just 1 Kelvin or 1 Celsius. Now we need to get the what's it called again? What is the unit of heat capacity? For us to get our unit, we have to know what our specific heat capacity is. And from this formula we showed you earlier, we said quantity of heat is equal to mass of the body times the specific heat capacity of the body times the change in temperature. Let's break it down again. Change in temperature is equal to the final temperature minus the initial temperature. That's theta 2 minus the theta 1, where theta 2 is the final temperature, final temp, and theta 1 is the initial temperature. Remember, temperature is always measured in Kelvin or degree Celsius. So from this our formula, we have to make C subject of the formula. We have to make specific heat capacity of the body subject of the formula. So we divide both sides by mass and change in temperature. So change in temperature cancel change in temperature. Mass cancel mass. And here we do the same, but you can't go because they are not like terms. So we say C is equal to Q over M change in temperature. Now carry anywhere we see anywhere we see C now, we put we substitute it for this equation. Anywhere we see letter C in this equation, we take this Q over M change in temperature and put, because what we are saying here is that C is equal to Q over M change in temperature, and Q over M change in temperature is equal to C. So wherever we see specific heat capacity of the body, remember this is the SHC. This is the specific heat capacity of the body. So anywhere we see this, we put this. That's what we're going to do. So taking this equation here, I'm putting it inside this equation. We have heat capacity equals to mass times Q over M change in temperature. Mass will cancel mass because it's like time. And we have H equals to Q over change in temperature. Now remember that Q is measured in joules and change in temperature is measured in Kelvin or Celsius. Forgive my spelling, I don't know if I got it right. And then putting it in the unit equation, we say quantity of heat is equal to joules is J, denoted as J per per. The unit of heat capacity is joules per Kelvin, joules per Kelvin, or joules per Celsius, or joules per Celsius. Degrees Celsius. We can also put it in index form and we'll make it to be like this. J per Kelvin or joules per degree Celsius. Joules per degree Celsius. So this is the unit of specific heat capacity. Sorry, this is the unit of heat capacity. Note this unit. I want you to note it in your head. Whenever you see an equation, whenever you see a number that has this unit, it means that this is heat capacity. While specific heat capacity, this is the unit of specific heat capacity. Joules per kilogram per Celsius, per Kelvin, sorry, or joules per kilogram per Celsius. Because here, anytime you see kilogram in the unit, in any of these units, just so that it's specific heat capacity. Just so that we're talking about specific heat capacity. Because in specific heat capacity, the unit mass is required. So the amount of heat required to raise a unit mass of a substance by 1 Kelvin or Celsius is what we call specific heat capacity of that body. Now take an interesting question in JAM. The question goes like this. I can't remember the number, but it's a JAM question. It goes like this. The amount of heat required to raise 10 kilogram, the amount of heat required to raise 10 kilogram, 10 kilogram of a body by 1 Kelvin is called what? Now, in this question, can you say that they did not use the word unit mass, but they gave you the mass of the substance of copper actually. The question says the amount of heat required to raise 10 kilogram of copper by 1 Kelvin. 10 kilogram of copper. This is the mass of copper by 1 Kelvin is what? The answer is specific heat capacity. The answer is specific heat capacity of that body. Anytime you say mass, anytime you say unit mass or any number in mass, just know that the answer is specific heat capacity. So the amount of heat required to raise the temperature of a body is by 1 kilogram, by 1 Celsius or Kelvin is called heat capacity. The amount of heat required to raise a unit mass, the amount of heat required to raise the temperature of a unit mass of a body by 1 Kelvin or 1 Celsius is called specific heat capacity. So this is for heat capacity. We're still going into the topic. So stay tuned. We'll see you.